Okay, grade 12, there's nothing new here. It's just some slightly harder examples. And the reason they are harder is because, unlike example 8 and 9, these ones don't tell you what triangles to prove similar. You have to figure it out from the questions. All right, so I'm going to help guide you to see which triangles you've got to work with. So it says in circles A, B, C. All right, so let's highlight A, B, C. It's a bit big. All right, we have then A, B, D, like that. Then AC is a tangent to ABD, so we're going to keep that green going. And then AD is a tangent to the yellow one. Prove that. So for A, it says prove that BC AC ratio is equal to AB AD ratio. So we've got to find two triangles that have those letters in. All right, that we can also figure out a way to find equal angles. So if we look at the diagram here and we pull out ABC, so the triangle ABC, it traps A1, B1 and angle C. And then in the right-hand side of the picture, we get a smaller triangle ABD that traps A2, B2, and D. And the reason for that is because then I get my AC, I get my BC, I get my AB, and I get my AD. Right. Now, this triangle here, please note, it's not right-angled. It kind of looked right-angled. Okay, if they don't give you clues to make it right angled, then it is not right angled. Alright, so that's going to be BD. Okay, and B2. Please label exactly the numbers from the question. Alright, so we've got everything that we need now. Let's now go into our original picture and see what we can prove. Now, in this case, we will have from this tangent to this chord AB. So tangent goes into the green circle, hits AB, and that makes angle D. So A1 is going to equal to D because of tan chord theorem. So A1 equals angle D tan chord. Then from this yellow tangent into yellow circle, it's going to hit AB again. AB is going to make angle C. So we have A2 equal to angle C by tan chord, which then by default makes B1 and B2 equal because of angles of a triangle. All right, so we had to figure out which triangles to work with, unlike the previous examples. But if you just use the ratios that they give you, it leads you to the triangles that you need. So we're going to start with, in triangle ABC and triangle ABD, we had angle A1 equal to angle D because of tan chord theorem. Then we had angle C. So this is the first triangle I'm working with. So angle C is equal to A2 tan chord theorem. Okay, so the first lot of sides must come from the first triangle, the second lot from the second triangle. And then so angle B1 is equal to B2 by default for angles of triangle. So therefore, now we've got to label it in this way. Triangle ACB is similar to triangle DAB, because of angle, 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 or equiangular. Then we do our loops. So first two in one color, second two in another, and then first and last. And then we can go on to our question. So our question wants us to see that we have BC over AC equals AB over AD. Now, if we get two colors, well, two pairs of colors, then we work out. So let's see, we need BC. BC here for me is green. BC over, we need AC. AC is yellow. So we better hope that we're getting green and yellow on the other side. So then I need, according to the question, AB at the top. So AB, good, here is green. Over, we need AD at the bottom. Perfect. So that is true because we have similar triangles. Triangle ACB is similar to triangle DAB. All right, so they're matching sides. That's what the loops are representing. Their corresponding matching sides are in the same proportion. If you suddenly had a blue set of letters coming in, then we've messed something up. Then it's not working. So you need two colors from each triangle. Then for question B, it says that we are required to prove. Okay, so if you look back at the question, AB squared equals BC times BD. Now, this is similar to one of the ones in the previous examples. If you see it written like this, imagine how would have I got AB squared by cross multiplying? I would have had it as an AB and an AB. So whenever you get the squareds, make sure that you separate them on opposite ends. And so if you cross multiply, you get squared. So then BC and BD, doesn't make a difference which one goes where. So that's actually what we're trying to prove. So we have our loops. We need to find an AB in one color and AB in the other. So there's an AB in blue in the first triangle. And then there's an AB in green in the second triangle. All right. And that's why I didn't want to, in this one, if I'd used the AB, let's just go back for a second. If I'd used the AB from here, because we needed AB at the top. So I would have used BC, AC, and AB all from one triangle. You can't use three things from one triangle, and you also can't have three different colors in your ratio. So that's why I needed to use my AB from this one. My AB from this one, so that I can match green to green, yellow to yellow, and also only have, we had two from here, and we had two from here. Okay. So then going back here. So I've got AB in two triangles, two different colors. So now I better hope that BC and BD have those correct colors. So BC is in my first triangle, and it is, yay, thankfully, green. So we better hope that the BD that we need in the question is blue. And yes, it is. It's the big loop on the second triangle. DB or BD is the same thing. So then that's not what the question asked. The question asked us to prove that we could get them in this orientation. So yes, AB squared equals BD times BC, or BC times BD. And this is because we have similar triangles. Triangle ACB is similar to triangle DAB. So if your colors don't match, it means that your similarity proof was wrong. You didn't put it in the correct order here. So your loops will match, and so you will always be able to prove this combination. It's just about the right colors. All right, so you pick the loops, and so if you have multiple sides in triangles that are the same, like the AB and the AB here, in this one, the AB is blue, and in this one, the AB is green. So you've got to try and pick the right AB for this first question here. We said we want that AB. We want the green one, not the blue one, because the other two sides from the triangle have been used. So you're only allowed to use two loops from each triangle, and they must match in color. 2 colors, 2 pairs. Okay, moving on to example 11. So example 11 is also a little bit tougher because they don't tell you which triangles. So let's see what we've got here. We've got PQ and PS are tangents to the circle. So PQ and PS are tangents to the same circle from the same point. So already you should be thinking, hey, I actually know a rule for that. Okay, so we would work with tan from same point, but that would give us equal sides. But equal sides don't help you here because we need equal angles for similarity. So don't get your 2 sections confused. And then they tell you to circle QRST, and those points are all on the circumference of the circle. And then ST, RS and RQ are chords, and QS is joined. So there's no center of the circle given. PQ is parallel to RS. So you must think, what do you know when you have parallel lines? You have fun, corresponding co-interior and alternate angles. Prove that QR squared. So when we see this QR squared, it means we are going to need a QR in 2 different triangles to get the squared. And we need an RS and we need an RP. So let's find the QR. Here's QR. Okay, where is there an RS? There's an RS. Here's an RP. Okay, so this QR is in 2 separate triangles. So I would go here and here. Those are the 2 triangles I can see overlapping. So we've got these 2 triangles. All right, so now we're just going to figure out which angles are equal by using the original diagram. So let's go back here. Okay, so I'm just going to highlight the triangles so that we can see where we're working. All right, so here we have a tangent. Tangent hits a chord. Chord makes an angle. So there I've got Q1 equal to S2 tan chord theorem. All right, now we only need to find one more pair because the third pair will be equal by default because of angles of a triangle. So now here, this one's a little bit harder to find. We've got to use the parallel lines because that's why they gave them to us. And I can definitely see a butterfly or a bow tie here. So let's just see what we can work out. So we need to work with either a Q2, a P1, R1, or R2, and 3, because that's what's left in the triangle. So let's have a look. Let's go with, we know that Q2 is going to be equal to T because of the butterfly, angles in same segment. But angle T, there we go, we can link it to P1 because of alter angles. And so that means if Q2 equals T and T equals P1, P1 and Q1 are equal to each other. Q2, not Q1. Q2 are equal to each other. And then by default, then R1 and the R2 and 3 are going to be equal. So let's just set this out now. So in triangle QPR and triangle QRS, we know, so that's the first triangle that I'm working with. So Q1 is going to equal to S2 because of tan chord theorem. Then, so that's for angle 1. For angle 2, we have Q2 equal to T, angles in same segment. But T equals P1 because of alt angles. Please don't forget your parallel lines, otherwise you don't get a mark for that step. Therefore, since both equal T, Q2 must equal P1. I just want to swap that around because P1 is in my first triangle. So I just want to make sure it's in the right order. So P1 is equal to Q2. Right, so anything in the second triangle is in the second column. And so what are we left with? We're left with R1 in the first triangle must be equal to R2 plus R3 in the second triangle, angles of triangle. Therefore, now we've got to watch out here. QPR, triangle QPR, you have to take the final statement of each, is similar to SQR. Okay, and I know that you guys are used to seeing sides in alphabetical order. Please, it must not be in alphabetical order. It must be in the order you proved it. So that is angle, 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 or equiangular. So then now to do my loops, I'm going to use yellow, yellow, green, green, and then let's bring in, say, purple, purple, purple. So then now we can answer the question, do we have a QR in two different colors? Yes, thankfully we do. So I've got a QR in pink over here and a QR in green over here. Right, so we're going to write that out. So we've got a QR and we've got a QR. Okay, remember we need them numerator and denominator on opposite sides, so when we cross multiply them we get the QR squared that the question asked for. The question asked for QR squared equals RS times RP. So let's hope that we have an RS and an RP in those colors. So let's see, RS, yes, I've got it here in purple, RS. Now it doesn't matter that they are on the same side as long as we get a green. So as long as we have two purples, two greens, then when we cross multiply, it sorts itself out. So then we need an RP, yes, in green. Great. And the reason we're allowed to do this is we have similar triangles. Triangle QPR is similar to triangle SQR, as we've proved. So when we cross multiply these guys, we get QR squared equals RS times RP. RS times RP, which is what the question wanted. So the point of these questions is to figure out which triangles you have to prove similar, prove them similar, and then make sure you have two colors, two pairs from two different triangles. So here are this one came from here, that one came from there, RP came here, or QR came from there. All right, so two triangles, two colors, two from each. Okay, so please make sure that when you're practicing now with exercise 5, that you are looking for the triangles you need and that you use colors. Okay, please use highlighters or Kokies or something like that to help you. All right, so for exercise 5, questions 1, 2, 4, 5, and 7, the whole exercise will go up onto Google Classroom, but only the memo for those 5 will go up. Again, if you want to practice extras, you're more than welcome to, but then you just have to contact me either when we get back to school or via WhatsApp or on the Google Classroom, and then I can send them to you individually just from the teacher's guide. Okay, but the handwritten memos with the colors from me will be posted on Google Classroom.